welcome to episode number 3 of Make It Work. So this week, as I mentioned last week, we're going to learn a little bit about adding buttons to the Arduino. So before the show, I've already wired up something I'm going to go through. I'm going to review it and everything, so don't worry. It's really simple, and we're going to walk through creating a real simple button interface that basically turns a light on and off. And then we're going to look at some of the options of something called a debounce. And we don't think about this very often, but the computer thinks so fast when our fingers hit the button, we think it's being pushed, but really the Arduino may see it being pushed multiple times. During a push or a release, it may see what's called a bounce. So we're going to create a debounce routine. And then I'm going to reverse what I did on the breadboard and show you how to do it a different way. Not necessarily a better way, but it's a different way. We're using one of the features that's built into this chip, the Intel chip. So first, let's hop over to see the Arduino, and we'll talk about a little bit like what I have set up here already. All right, so here's the Arduino, and same Arduino we used last week. And you'll see a breadboard sitting right here. And this is a very basic breadboard. That's one of my old ones that I have. And I'm going to go through some of the wiring after we get done looking at the program. But let's talk about what I have here. I have an Arduino. I have a breadboard which has no logic in it at all. And basically a breadboard is designed to do rapid prototyping. So basically you run wire from hole to hole. Now on this breadboard, these outside 2 rows, each row is separate whole way across or halfway across, and you see I jumpered it across, so this whole row is 1 row and this whole row is 1 row. And you can't see this in the camera shot, but at the top it's the exact same thing, so I have 2 rows up here as well. And then in the middle, these columns are all the same to the middle. So this column from here to here is 1 column. So if I plug a wire in here and plug a wire in here, they're going to have the same thing on them. And the same thing goes with across over to here. So that's the basic idea of a breadboard, is be able to easily push without soldering a wire into it to one component, then run it to another component and have multiple connections off of one component as well. And we'll see that in the button, because I actually have one of the button returns has 2 things in that one column. I'm going to keep calling them columns. So we'll show you that when we get into the actual design of the circuit based on the program. And for the program, what we're going to do, well, first of all, before I go, on the breadboard I have a button right here. And you see when I hit the button, a light comes on down here. You see it right down here. Maybe you can't see it in the camera. So you see the button comes on. And I have a resistor, which is part of the circuit, and I'll explain the purpose of the resistor as well. So let's look over at my computer. Let's hop over to there. Camera 3. Here we go. And on my computer, what I have is I've loaded, I'm going to go load it again so you can see how I did it. Let me load the Arduino again. And if I go to File and go to Examples and Digital, we're going to look at the button code. So we'll load the button code. Let me get rid of this and make this bigger. We look at the button code, and it basically says that it turns on and off a light emitting diode, an LED, connected to pin 13 when pressing the button attached to pin 2. So the LED is attached from pin 13 to ground, and as we mentioned before, this particular board and most Arduinos for that have pin 13 already attached to an LED. So we don't have to do this part. This part's already done. We need a push button that attaches to pin 2 and has 5 volts on it. So we have to do this. And then we also need to add a 10K resistor to ground to pin 2. So we have to do this as well. So let's scroll down and look at the code. A little fast on the scroll there. And what we see in the code is we're defining our constant button pin is equal to 2. And our LED, like in the previous example last week, is LED pin, and it's equal to 13. So now we have a button as well. So we want to keep track of what this button is doing. So we're going to create not a constant, but a global variable, because it's outside of any function. It's considered global. And we're going to call it button state. So button state equals 0 by default, meaning the button is not being pressed. And if we keep scrolling down, we have our setup routine, which the Arduino calls every time it boots up. And the first thing we do is we set the, like last week's, the LED pin, which is set to pin 13, to be an output pin. So we can control what goes out, which turns, so we can turn off and on the LED. Next line we have here is button pin. Well, we set button pin to 2, and we're telling it this is actually an input pin. So we want to be able to read what pin 2 is set to. So that's all we have to do in our setup routine. So let's go look at the loop now. And in our loop, we're going to set our button state equal to whatever the current state, digital state of the pin is. So if there's 5 volts on it, it's going to be equal to 1. And if there's not 5 volts on it, which should be ground, it's going to be equal to 0. So here we come down and look and see the button state. So if it's high, which means the button is being pressed because it has 5 volts on it, we want to turn the LED on. So we set the output to the LED pin, which is 13, to high, and turn the LED on. However, if this is not high, which means it's going to be low because it's only high and low, it's going to go down to else, and it's going to turn off the LED pin. And that is all there is to the program. It is really that simple to write a program that turns an LED on and off based on a button push. Now, there's a couple of things we need to talk about in laying out the breadboard and the circuits. And one of these was mentioned at the top about running a resistor, a 10K resistor, to pin 2 from ground. And the reason we do this is if you don't put it to ground, the pin's going to fluctuate. So what you'll see is the light kind of dimly blinking, acting kind of funny. So we need to make sure we do this, and we can even demonstrate what happens when you take it out to show you what the result is. So let's hop back over to the breadboard and let's talk about some of the wiring that we've done here. Okay, so here's the breadboard and the Arduino. So what we have on the side of the Arduino, the red wire, is plus 5 volts. If you look down, and you can't read this probably on the camera, but if you look down in here on the side, it says plus 5 volts. It's also a plus 3.3 volts. And then you see a ground and a ground. So what we've done, we run the red 5 volts to this strip right here. So this whole strip right now is 5 volts on it. And then we run ground to the other strip on this strip over here. So this strip on the edge, the whole way up and down, is ground now. So we come over here and look a little closer on the breadboard, and you see I've jumpered from the plus 5 volts to this column right here that has the switch in it. So this switch, side of the switch, is attached to 5 volts. What I've done on the other side of the switch is I've jumpered the 10K resistor right here from ground to this column right here. This was the other side of the switch. And then it also jumpered from this column on the other side of the switch from here over to pin 2, which is right here. So this completes our circuit design. So what's happening is I have 5 volts that's going to the switch. This back side of the switch, because it's not being pressed, is right now to ground through this 10K resistor. When I press this button and the LED comes on the Arduino, 5 volts is now traveling down this line to pin 2. When I let up, it's connected back to ground because of this 10K resistor. So the resistor being 10K, 5 volts won't transfer through there. So there's enough voltage on this for the Arduino to say, hey, I got voltage on that input, so I'm going to turn on and off, just like this. Now, here's this 10K resistor. I'm going to take it out like this, and we're going to show you what happens. Right now it's unplugged, and it looks like it's normal at this point. When I hit, I'm only hitting the button. I'm just getting close to the wire. See it come on and off like that? That's because it's floating right now. If I hit the button, obviously it comes on. Now it probably won't go off. It might go off eventually. We see me tapping, it's going to go off. So it's very unpredictable. So what this 10K resistor does is it pulls that circuit or that pin to ground, so there's always ground on that circuit when there's not 5 volts. So now you see we're back working again. So that's the important purpose of this 10K resistor. You need to make sure you know what state that input is on, because the Arduino can definitely misinterpret just little voltages as being an input. So that is the simple circuit from the example that is in the Arduino software. And what I want to do is there's another example, and I want to explain the reason we do this as well for button input. In this particular case, what we're doing is we're saying, if I see input, turn the LED on, or if I don't, turn it off. But what you probably can't see that could be happening is called a bounce. When we push this button, we think it's down, but the Arduino reads it so fast, it may get multiple button pushes, or button releases for that matter, when we hit that button, because it's much faster than what we are. So that's called a bounce. If you are trying to do, for example, count an input, like count how many times the button is pushed, you may hit that button one time and get 10 key reads, or 10 push buttons, just by doing that. That could be equal to 10. Not because of how long I'm holding it, but because the bounce down and the bounce up generated, one generates 7, one generates 3. So the way you get around this is you actually delay. So you read your input and you wait till you read again. And that's what we're going to talk about next. We're actually going to go look at a debounce circuit, or debounce codes on the computer. So now we're back at the computer. Let's go ahead and we're just going to go to File. There's a great example in here about this. And go to Digital, and you see debounce right here. So we're going to load debounce. Let's make it big on the screen. And it even explains basically what I just explained, that each time an input pin goes from low to high, it's toggled low to high, high to low, and the minimum delay in here kind of takes the circuit noise down, or the bounce down. And this is the exact same circuit we already have, so we're not going to change anything on the breadboard. This is all software at this point. So let's scroll down here to the code, and you're going to see it looks very similar to the other one because we're using button pin 2, or button pin is equal to 2, sorry, and LED is equal to 13. And then we're going to set the LED state to high. And the reason we're setting state on an LED here is we're not just going to turn it off or on. We're going to toggle it off and on every time we see a transition from low to high or high to low. So you're going to be able to see a bounce problem here if it exists. We have a button state, and then we have our last button state as well. So these are all not constants. These are variables that can be set throughout our programs, and they're global variables as well. Then we come down here and we have the debounce delay and the last time that the output pin was toggled. And these are used to determine if it's actually a bounce or if it's not a bounce. Then we get into setup, same setup as our last program. We're going to turn the button pin into an input, which is pin 2. And it's LED pin 13. It's going to be set to output. And then here's where things start to change a little bit. So here we're in our loop, and we're going to read the state of the switch into a local variable. So we've read the button pin, which is pin 3, into a variable called reading. And if the state has changed, see here you see if the button input went from low to high or high to low, either direction, we want to look and see if it's been long enough to accept the input. So here we're saying that we have read it, and what we've read isn't the same as last time we looked at it. So something has changed. Either it was pushed or was let up in either case. So we set the last debounce time to the current number of milliseconds on the clock. And if we come down here and we say the current milliseconds is minus last debounce time, which is what we just set right here in this particular time, is greater than the debounce delay. So up top, we set debounce delay to 50 milliseconds. So what we're saying right here is if we see this difference, say the last debounce time minus the current milliseconds, and the difference is greater than the 50 millisecond delay that we have currently set, we want to go ahead and change the button state to say, okay, it's okay to accept that button state. It's been long enough. And then we come down and we actually write the LED based on what our current button state is. And then we set the last button state to what we just read. So if it changes again, we know we need to go look at it again. That's it. It's a little complicated when you first look at it, but I'm going to go through it at a little bit of a high level. So here we go again. We read the button state. We see if it's changed. Has the button state changed? And if it has, we set our last debounce time equal to the current number of milliseconds. And then the other comparison we do after that is subtract the last time we saw a bounce from the current milliseconds. And if it's greater than the debounce delay, we change our button state to what we just read. So what will happen in a case where it doesn't change is it's going to skip over this right here. It's going to come into here, and it's going to set this button state automatically because it's been longer than 50 milliseconds. And it'll write the pin out. But the pin's not going to change because it's already in that state. It seems like it's a little confusing there because of that. It'll go through this routine right here anytime it's greater than 50 milliseconds. So if it's been 10 seconds since you've pressed the button, it's still going to set button state to the last thing that it read. It's just and it's going to set the button state on the LED based on the button state, but it's doing it so fast the LED doesn't blink and it's not changing state. The LED's already like that, so it's not making a difference. And that's pretty much it for this button bounce. Now we're going to run it here. Let me go ahead and upload it. Okay, it's up there. Let's go back over to the Arduino. And we're going to see what it does. So we're currently running a 50 milliseconds delay. You see a little bit of delay in the button as I'm letting up and down. It's not too bad. So that's doing the debounce check right there. So we're checking it, and that's a more consistent way to check your button. In particular, if you're counting something, or if you're setting some kind of command, you don't want to send it 10 times when the button is pressed. You only want to send it once. So that's the best way to wait for a debounce. Now, there is one other thing on this week that I want to cover with buttons, and it's the opposite of what I'm doing right here, basically. And there's actually a demonstration of this in the Arduino code, which I did not know. I was creating one to demonstrate it, and they actually do have one. Some of this code, I believe, was created before some of these chips that we're using today were created. A lot of these chips, these new chips, have built in what's called a pull up or pull down. And in the case of this one, we're using this resistor as a pull down. So we're pulling down to ground. And you also can pull up to 5 volts. So some chips can do both. Some can do one or the other. This chip right here, I think, can only do pull ups. The one that's in the new Arduino, I think, can do both. I may have that wrong, but I'm going to demonstrate. It definitely does pull up because I've checked this already. So here's what we're going to do. We're going to go back over to the computer, and we're going to look at what it tells me to do for our wiring on the breadboard. So let's hop back over to the computer, and we're going to go to examples, digital, and digital pull up. And we're going to maximize this. And actually, you can see this date is much newer. So it's 2012. So I think I'm probably correct with what I was saying before about the chipsets, because the other ones were from 2006. So here what we're going to do is we're going to only attach a switch and an LED. We don't need this resistor. And I'm going to show you why this is. And in doing this, we're actually going to reverse how this is working. So this reads a digital input on pin 2. So it's the same pin we've been using. And we're going to use the built-in LED on pin 13. We're going to ignore the fact that it's writing out serial code as well. In fact, I may even comment it out to show you how to comment out code through this. And so here's what I was saying before. There is no pull-down resistor because it's not necessary. It's an internal resistor, and it's pulled up to 5 volts. So what we've been doing before is we were saying that when I got 5 volts, turn the LED on, and when I didn't have 5 volts, turn the LED off. Now we need to reverse that. So when I have 5 volts, the button isn't pressed. I need to turn the LED off. But if I don't have 5 volts, I've gone to ground, and I want to turn on because the button is pressed. So this is, like I said, reverse of what we did before. So let's come down and look at it. We're going to comment out serial. We don't want to do serial, so we're just going to comment that out. This is for serials for another day. I think it may be next week or the week after, as a matter of fact. So we're going to set pin mode 2. You notice we're not using variables here. We're using actual pin numbers. So a little different developer. You create as a sample. We're going to use pin 2, or we're going to set the input, and we're going to use Pullup, which means we're going to pull up to 5 volts. Pin mode on 13 is again output, which is our LED on the board. And then we're going to read the push button value into a variable. So here we say the sensor value, which is basically is a variable that's going to hold what pin 2 is doing. And we're not going to print out the serial value. We're going to comment that out. And here in his code, he's very good at commenting. And he even says, keep in mind the pull-up means the push button's logic is inverted, which is what I've been saying. So if sensor value is equal to high, which means the button is not pressed because it has 5 volts on the pull-up, we go to digital write, turn off pin 13, set it low. And if it is low, or the opposite of high, then we want to turn on the LED. So that's all there is to this code. Very simple. And again, it's reversed. So you will basically be, when the input says it's on, it really isn't on as far as the button is concerned because it's pulled up to pin 5 or to 5 volts. So here's what I want to do. I want to before I load this, well, we'll go ahead and load it. We'll see if it should be backwards from what we're used to. Let's go ahead and upload it. All right, and let me go over to the Arduino. Let's see, Arduino is, and here we are at the Arduino. So now we have this loaded, and you're going to notice obviously it's going to be backwards because right now it's pulled to ground, so it's going to be on because the button isn't pressed. And this is basically opposite what we're going to have because we're going to pull it to ground. Right now we're always pulling it to ground, but when we put 5 volts on it, we override that. So you see right here the light on the Arduino, and when it's on because I'm not pressing the button, but when I press it, it goes out. So the reason it's backward is we're forcing this to be to ground. So here's what I'm going to do. We are going to pull this resistor out because we don't want it. We want it to be 5 volts. So we'll pull this completely out of the way. And we, instead of putting this to 5 volts, we want to put this to ground. So let me get a different jumper. And we're going to put from ground, which is this side, to this column. Oops, put it in the wrong one. Okay, so there we go. From ground to this column. So now we push the button, we get what we were looking for. What this also means is this 5 volts that I ran before, I can actually take completely out. That would have actually made this a little bit easier before. All right, so put this pin back in. Now you'll notice I don't have any 5 volts on this board. I have pulled it completely off and our light still works. So what is really happening, if I would take a meter and measure this wire right here, I would find I have 5 volts on it. Because the Arduino itself, the chip, is putting 5 volts on this pin. When I push this button, that 5 volts goes to ground, which basically completes the circuit, and the Arduino doesn't see it anymore as 5 volts. It's being pulled away from the Arduino. So I push the button, the 5 volts then finishes the circuit. This button finishes the circuit, 5 volts goes away from the Arduino into the ground, and the Arduino sees that pin go low. And then in our code, when we see the pin go low, we actually turn the LED on. So right here, we're not high because we're hitting the button. So we're low, we turn the pin on, we turn the LED on. So this is reverse of what we did before. But the advantage to this is it's using no external parts other than a switch. There's no resistor required in this design. Now, like I said, I think the new set of chips that are out, which I'll be able to confirm this for next week, has pull up and pull downs, so it would not be backward in the code. But I'm not positive about that. I think as well as reading in the specs for the chip. So we'll have to confirm that. So far this week we have shown you how to use a button, how to do a debounce, and how to use a button using the new chips that have a pull up in them as well. That means no resistor is required. So we have gone through all 3 different button styles. Next week, we're going to focus on a shield. We actually got an LCD shield that we want to show you. It's a very easy to use shield. It's the first one we've gotten that we actually really liked as far as ease of use. So we will come back here next week and we'll show you the shield and a few other things. So a few housekeeping things. If you're watching us on YouTube, please subscribe. We'd like to know how many people are using YouTube. If you're watching us on a podcast or on your TV at home or some other method, you be sure to subscribe. If you're using iTunes, it's an easy click to subscribe right from the Make It Now, or I'm sorry, Let's Make It homepage. You can subscribe to all the different places we have our netcasts hosted. And if you're around on a Wednesday night and you want to hop into the chat room, we definitely appreciate that. It's definitely growing. We got some more people in last week than we had the week before. So every week it seems to gets a little bit better. And we hope that continues because we do really like the feedback in the chat rooms. And even if you don't in the chat room and you're watching this not live, your feedback is always very greatly appreciated. You can just send email to let'smakeit@tech-zen.tv. Also on the show page, there's links for that. We have a Twitter you can contact us on. You can also call our Google Voice and leave us a voicemail. And you can also join with everybody in the community, in our TechZen community. It's not just about this show, it's about all the shows that we have, but we definitely enjoy people coming in there and commenting and really thrive on your feedback. And if something particular about the Arduino or any kind of embedded systems programming that you have questions about, want to learn something about, please do not hesitate. The Arduino isn't going to be the whole about this show. We are going to talk about other things coming up here. Raspberry Pi being one of them, because we're pretty impressed by the Raspberry Pi for what it is, and its price especially. I mean, it's a pretty amazing piece of hardware. But we have other things. Our backgrounds in PIC chips, and we're going to talk a little about those and different ways of developing. We're getting ready to probably start designing a new PC board, and we're going to walk through schematic designs using some of the software that we use, demonstrate that, and also PC board layout, which is all part of the same thing in production of that. So we're going to go through and talk about all these different things coming up. The Arduino is very impressive and is right now our major topic just because of its ease of use to get people started in this. But we do plan to take this to be a little more technical and a little more in-depth as we continue along. All right, well, that's it for this week, and we hope to see you again next Wednesday night. Have a go week and play with that Arduino.